Okay, so basically question 4 is asking if you have two devices that both can send you the interrupt, and so basically the signals coming from the external devices are called interrupt request. Okay, interrupt request 1, interrupt request 2. And then also if processor mode is given, so basically processor mode is the last step, means what's actually happening on your processor. Okay, so if you know, so basically if you know the very first step, okay, if you know the very first step and if you know the very last step, okay, so you can draw the two steps in the middle. Okay, so the two steps in the middle are pending signal. So pending signal means, okay, there are pending flags inside your NVIC. Okay, it's to indicate, okay, it's to inform your processor that, okay, there's an interrupt that it needs to handle. Right? So it's an indication. It's an indication. And active signal is to inform your processor that at which moment exactly you need to handle the interrupt. So basically, you can draw the active signal directly by the processor mode. Right? For example, here you are handling the interrupt, so there is a corresponding active signal for either interrupt 1 or interrupt 2. Okay, and here you have handler mode, so this is for interrupt 2, and here you are running handler two times. Okay, so this is for interrupt 1, and you are running interrupt 2 times, so you can derive the active signals. Then once you know the active signal, you know the interrupt request, you can draw the pending signal. Okay, so pending signal is basically the flags here, so it will be set to 1 once there's an external information coming, right? And the question told you that there is a delta t time delay, so every time when there is a rising edge of the interrupt request, which is actually the external signal, you have a delta time delay, then your pending signal goes to 1. And it will stay as 1 until the moment that your processor is able to handle it. It gets cleared immediately. Okay, so using this strategy, you can derive your pending for interrupt 1 and interrupt 2. And here, okay, so sometimes your pending signal will stay for quite long. Okay, this is because of, okay, or sometimes your pending signal, okay, your pending signal can be, set one more time if there's an external request coming again. Okay, so that's the meaning of the different signals. Now we are going to work on another one. So question 5, okay, you see that the only signals given is interrupt request. Basically, these are the external signals. So these are the external signals coming from the devices. Okay, and this time we need to derive all the other signals until your processor mode based on this signal only. But to do that, you need much more information. Okay, for example, okay, see what information do we have? The pending signal are delayed by 1 delta time from the interrupt request signal. Okay, it's similar as the previous question. So whenever there's external signal coming, your pending will be delayed by 1 delta time. So that is one condition, that is one information. Okay, and then the highest priority pending interrupt is processed right after its pending signal is active by 2 delta time. So basically this tells you how to derive the active signal if you know the pending signal, basically. Okay, so this means, okay, if the signal is pending and if currently this is the highest priority device, it will be handled as soon as possible, but not immediately, but 2 delta time delay. Okay, so there's another information 2 here. And of which 1 delta time is for saving the status of the preamp main program or the handler. What does it mean? Just now we said, okay, there are 2 delta time delay from pending to active. And why we have 2 delta time? So basically 1 delta time, okay, within this 2, 1 delta time is to save the status of the preamp main program. Okay, which means, for example, you are running your assignment 2, and for a certain moment, okay, the button is pressed, you are going to jump into your ENT3 handler, right? But before you jump to that, okay, some actions need to be done. For example, you need to remember where are you at this moment in your main program, because you need to remember the lines later on, you need to come back, right? So there are some things needs to be done before you actually jump to the handler. So it will take some time. That's why within these 2 delta time, one of them is to saving the previous status. Okay, so there's another information 3 here. And then restoring the status of the preamp main program or handler upon an interrupt return occurs 1 delta time. So this means, okay, once you have run whatever inside the handler, when you want to come back to your main program, it will take 1 delta time. Okay, so that's the idea. So I have 4 here. And also, there's 1 delta time delay between return from one interrupt handler and the beginning of execution of other. So this happens, let's say, when you have a lower priority device is running. Okay, let's say you have 2 things, you have SysTick and you have SW3, right? Let's say when SW3, ENT3 handler is running, but at this moment is the time that you need to increase your MS ticks by 1, right? We say time is more important, right? So most probably you will pause your ENT3 handler no matter where you are inside the handler. You will pause, you will go into the SysTick handler, right? To increase your MS ticks by 1. After that, you come back to where you came from, basically your ENT3 handler, right? So there's a like switching between one interrupt to another, okay, depending on their priority. So basically this switching will take 1 delta time. Okay, that's the idea. And then you also need to know, okay, so interrupt 1 has higher priority than number 2. Okay, you need to know the priority level. Okay, and then finally, the handler of the handler of interrupt 1 takes 6 delta time, and handler of interrupt 2 takes 5 delta time, which means, okay, the length of your handler. Okay, your handler has some code inside, so it takes some time to be executed, right? So basically, the handler for ENT1 will consume 6 delta time, and interrupt 2 will take 5 delta time. Okay, so you see all this information needs to be given so that now we are ready to draw all the way to the processor mode. Okay, so let's see how to do that. So, so I'm using different color. Okay, let's say, okay. So you have 2 devices, okay, sending interrupt request like this. Okay, and at the beginning, okay, all of them are 0, right? Until this moment, okay? Can you see this moment? Your external device 1 sending the request, right? Then what will happen? Your pending flag will be set, okay? But when will it be set? You have 1 delta time, right? Based on the information 1 you know. So basically, it will stay 0, but until this moment, it will go up. okay, you will have 1 delta time delay. And then it will stay 1, right? Supposed to be like that. Okay? And can you see at this moment, okay, at least at this moment, nothing else is happening, right? You only have interrupt 1. Interrupt 2 is not coming yet, right? So what do you need to do? Remember here, the highest priority pending interrupt is proceed right after its pending signal is active by 2 delta time. So now this is the only interrupt you have. Okay, NVIC only know, okay, this is the only one he has. He will inform the processor, and processor will be able to handle it after 2 delta time. Okay, which means, okay, your active signal, right? Active signal is the real moment that your processor is handling the interrupt, right? So basically, after 2 delta time, okay, so here, 2 delta time, okay, you are able to handle it now, okay? So this is a moment, okay, your active signal goes high. Okay, and once your active signal goes high, what happens to your pending? It will be cleared. The pending flag will be cleared, so it will go down in this way. Okay, and then, okay, so let's see what's happening for interrupt 2. Okay, you see, during this moment, interrupt 2 happened. So for interrupt 2, okay, again, it will stay at 0, 0, 0, all the way until this moment, okay, an external signal coming. Okay, again, you will have 1 delta time delay, right? After 1 delta time, your pending will go up, right? So here, you will get 1 delta time. But what's happening here? Can you see here? When this one is pending, what's happening in your processor? It's actually doing the first one, the device 1, okay? And by the information, you already know who is higher priority. The first one, okay? So this means this active signal will keep running because it's the more important one. And the other one needs to wait, right? So you can draw, at this moment, you can draw your the first one, regardless the second one, right? So the first one active, it will active for how long? For 6 delta time, right? That's the time for your handler. So basically you will count, okay, 1, 2, 3, 4, 5, 6, and then you will go down. So basically here you finish your first interrupt, right? Then for your pending, what's happening for the second one? Okay, you see for the second one, once it's 1, okay, the first one is handling. That's why we say it needs to wait, right? Wait until your processor ready. So basically, your pending will stay as 1. Okay, pending is a flag that indicating your processor, okay, something you need to do. So this one will stay for long, until when? Okay, so basically this is a moment your processor finished the first handler. And at this moment, he also know that, okay, there's one more that he needs to do. So this is a moment, as I said, is a switching between the first interrupt to the second. Then how long it will take? Okay, so there's 1 delta time delay between return from the one interrupt handler and the beginning of executing the other one. Okay, so which means here, if I draw the active signal for my second, it's not able to do anything until this moment, right? Because here you will have 1 delta time to switch between the one interrupt to the other. Okay, so this is a moment your active signal for the second one, and this is a moment your pending get cleared. Okay, so your pending get cleared here. Okay? So basically up to now, we finish the first two. Okay? Now we also need to draw your processor mode. Okay, let me use another color, your processor mode. So processor mode, remember in the previous question, processor mode is given, we can derive back your active mode. Now you have the active mode, you can easily draw your processor mode. So basically at this moment, it should start to handle the first one. So basically it will stay for this much. So it will take 6 delta time to do, right? But there's also something given here. Remember, there's two delta time, which is here. Okay, so from here to here, you have 2 delta time, right? To go from pending to active, right? And of which one of them is saving the status of preempt main program. Okay? So these are the moment that you go from pending to active. And this is the moment your processor go from regular routine to your handler. Right? It will take 1 delta time delay. Right? So we can draw in this way. So basically it start to switch from the main regular routine to the handler mode. So we can draw a slope taking 1 delta time. Okay, so this is a switching between regular routine to handler mode. Okay, and then at this moment, okay, here you finish the first one, you need to run the second one, right? Remember here? Okay, here it will take 1, 2, 3, 4, 5, right? I haven't completed here, so here it will take 5 units of time to complete the second handler. So here it will take 5 units of time go down. Okay, so here for the processor mode, okay, so basically what's happening is you go down, but you go up to handle the other one. 1, 2, 3, 4, 5. Then you go down. Okay, so this is a 1 delta time delay to switch from one interrupt to the other, one handler mode to the other handler mode. Okay, so up to here we finish this, and then now continue. Along the time, can you see that your device 2 give you the interrupt request now? Okay, at this moment. Again, you will have 1 delta time delay to pending, right? So here you are pending in this way, right? And here 1 delta time. And can you see at this moment, okay, all the way up to here, your request 1 is not coming yet, right? So basically, now your processor can handle interrupt 2. This is the highest now, highest priority one, right? So what do you know from the question? It will get handled right after 2 delta time, right? So which means here, after 2 delta time, your processor is now able to handle it. Okay, because now you only have, okay, so at this moment, your 2 is not coming yet. Okay, and then at this moment, okay, 1 is coming at here. So you're pending, okay, for this case, we need to draw these 2 together. So for the pending, you will have 1 delta time delay. It's rising up here, right? But can you see at this moment what's happening? Yes, your processor is working on device 2 now, right? But now device 1 is coming. Okay, device 1 is coming. So now you see this is a moment that your higher priority device kick out the other one. Okay, although you already run the second one, but it needs to be paused. Okay, so what's happening here is, okay, if you draw, so at this moment, okay, your device 1 is the highest priority one. And based on the information you know, it will be handled right after your pending 2 delta time. Right? So at this moment, you need to draw your interrupt 1 no matter what. So this one will stay for 2 delta time, go down. And then your active signal will be handled, okay, here, right after this amount of time. Okay? And it will kick out your second one. Run 6 delta time. 1, 2, 3, 4, 5, 6. It will run this much, go down. Okay? We just draw this no matter what because this is the highest. You can finish this already. Then now let's look at what's happening for our, the second device. So you see the second device, okay? Can you see at this moment? Okay, so at this moment is a moment that your processor needs to work on interrupt 1 already, right? And this is a moment, actually, is a moment you switch from interrupt 2 to interrupt 1. Okay, so before that, you need to take 1 delta time to get prepared, right? Which means, okay, here I can draw my processor mode first because I know exactly what's happening here. Okay, so for example, your processor mode. Okay, processor mode is get to be active at this moment because you're at this moment, okay, you only have a interrupt 1. So it will take 1 delta time. Okay, so basically here it will be shorter. It will take 1 delta time to go here and then start to run it. Okay, so basically you will have this all the way here and then it will take 1 delta time to raise up and then it will start to handle the second one. But at this moment, the next delta time here, you need to handle the first one. So there's 1 delta time transaction. So you have something like this. You go to run the other one. Okay, I just draw in different levels so that you know we are handling different interrupts. Okay, so here is 1 delta time here to switch, okay, between 2 interrupts. And then you are running your interrupt 1, so you will take 1, 2, 3, 4, 5, 6 amount of time. And then this is a moment, where should you go back? Interrupt 2, right? So again, it will take 1 delta time to come down. That's the switch between interrupt 1 to 2, right? And then you need to handle your interrupt 2. But how long you need to run? Can you see before you start to handle interrupt 1, how long have you run? 2 already. So this is like you are running halfway of your handler. You go back, you will run the rest of them. Totally, it should take 5, right? So you still need to run 3 times. And then you go back to the regular routine. Like this. Okay? And by knowing this, you can draw your active signal now. Okay, so now basically your okay, so basically here, as I said, these are the active moment for your interrupt 2. Okay, so basically interrupt 2 will be stay as 1 until this moment. It will stay quite long. Okay, at this moment you finish and then you take 1 delta time to go back. Okay, so that's the idea. So you see, in order to draw this, all the information needs to be given. Okay, so this is question 5. Which one?
Like the signal 2 and signal 1 supposed to be from must be same level, is it? I mean, not signal. Signal 2. Yeah, signal.
Which one? This one request or pending or active? Which one are you talking about?
Signal 1, active 1.
Active one here.
I mean, when the process move, right?
Mm.
So meaning that the signal
Yeah, here will be a line.
Yeah, the signal from active 1, the level, I mean the level should be same, right? Because
Here?
yeah.
No, here I just draw different levels, okay, so that you know here we are handling one, here we are handling the other one. But if I draw everything, it's just merged together. You cannot identify like at what time you are handling which one.
So what I mean is that this signal must be same and aligned with the
Here?
left side, yeah.
And the height doesn't matter. Okay, the height doesn't matter. Okay, so this is the one. Any questions? Okay, so the question is here. The answer is here. Then now the last one is a discussion question. So question 6, which registers do the following functions modify? So these are the 3 functions for interrupt priority setting. Okay, I think you have seen this one and this one in the lab. Okay, so it is asking which registers the functions are modifying. So there are many registers involved for the priority setting. Okay, I don't know how much detail the lecturer goes, but you just follow the guide for the exam. But whenever during the exam, if anything needs to be modified on the register, the table will be given, like telling you in this register which bit is for what function. The table will be given. Okay, it's not required to memorize everything. So here there are many registers. Okay, you can see there are many registers involved. Okay, for example, for the external interrupt, we can set enable and we can clear enable. You didn't see this in the lab because these are actually some registers. When you write something like enable your EINT3, you have function to enable the EINT3, right? So someone has created the function already. Inside it, you will see it's actually modifying set or clear the particular interrupt. Okay, and then you have set pending, clear pending. So basically, these are the internal interrupts that usually programmer doesn't modify them. So they are useful to do something like this. Okay, when we do this, okay, remember when this one is active, this one is cleared. Okay, and when the external request is asked, you set the pending. So those 2 registers are used to make this one as 1 and clear this one as 0. That's the purpose. Okay, so all this, okay, the process we are drawing now, okay, whatever process we did in our brain, okay, in the processor is done by the registers. Okay, it's done by the registers. So these are the registers to clear the pending, or set pending. Okay, and then you have interrupt priority register. This one you see, right? Because we need to define it. So okay, in case you forget, this one is a 8-bit, okay, 8-bit register that, okay, so basically 3 of them you cannot touch for our particular board. And you are using the other 5, okay, and some you draw a line, some of them are using for preamp, some of them are using for sub-priority, depending on your grouping, right? And then you can have interrupt active bit register. Okay, so this one is again, okay, this one is similar as your pending. There are internal registers basically to set this one. Okay, just now the registers is to set the pending, clear the pending. You also have register to set your active. Okay, to set your active. That's the idea. So we are not using it because once you set the priority levels to two different devices, just like the previous question, okay, your NVIC is actually handling those internal registers. Okay, your NVIC know exactly which one should be handled first and which one should be handled next. You know, so he is working on those internal devices, internal registers to draw the waveform like how we draw just now. Okay, and then for the system exception, okay, so basically this one you can consider this as internal interrupts. For example, your reset. Okay, for example, your hard fault. For example, your systics. Okay, they are internal interrupts. So you are using application interrupt and reset control register. This is mainly for the system exception. And then you also have some other registers can affect your interrupt process. For example, you can have mask, you can have fault, you can have base. Okay, so the idea is here, but I think in the lecture it doesn't mention this. I mean, this won't be tested, right? I don't know. But okay, one important thing here is this one I want to highlight. Inside your application interrupt and reset control register, you have bit 10 down to 8 is for your priority group. Okay, remember we use this one, right? For example, when group is 5, right? What we did is we choose 2 bits for our preamp and all the others for my sub priority, right? So this is also something we set, our programmer set, right? So basically how you set this number is you put the value into this bit. Remember totally how many groups we can have? Okay, it's 7, right? Remember here you have 0 all the way to 7. That's why inside that register you are using 3 bit. Okay, so here can you see bit 10, 9, 8. You are using 3 bit, right? Because there are 8 possibilities basically, right? That's the idea. So now look at the program. The NVIC set priority, this is a code. NVIC set priority. Okay? So can you see that you need a data type IRQN here. For example, you can put EINT3. Okay? I mean in the lab you put EINT3. But actually EINT3 is a constant you defined. Okay, there's a table. Okay, there's a table defining bunch of constants. For example, cystic is a number, referring to a number, and EINT3 referring to a number. Okay, so and then you can write a priority level that you want for this particular interrupt. And then inside this code, can you see you have 2 options. Sometimes your IRQN, which is your first parameter, could be a negative value. That's why if you look at this table, okay, inside this table, every interrupt is referring to a number. So actually you can see that there are some negative values, there are some positive values. And the negative values are all for your system exceptions. Okay, so if I show you the lecture notes, okay, interrupt. Okay, so if you look at this table, where's my system exception? Here. Let me see, there's another table. Okay, maybe this one. Okay, so if you look at this table, okay, so these are the system exceptions. You have reset, you have hard fault, okay, you have bus like busy, and you have like cystic here. Okay, Can you see that? The priority usually we give a negative value. Okay, so basically we assign them as negative values, and all your external interrupts, they are having a positive value. Okay, that's why in your program here, okay, so when you write ENT3, because it is external, okay, and in the library based on this table, okay, whatever table here, ENT3 is referring to a positive value because it's external. That's why in the code here, you are going to the else condition and you are changing your IP register, IPR basically. Okay, but if we are doing, let's say, SysTick, okay, SysTick in this table is referring to a negative value because it's a system exception. Okay, and then what we're actually doing is you will go to the if loop and you are setting the SHP register. Okay, so SHP register, did I list it here? But it's actually equivalent, it's quite similar as your IPR, but they are completely used for the system exception. Okay, so basically this function can either change your SHPR or IPR, depending on whether you are setting the system exception or external device, external interrupt. Okay, and then the other one, NVIC set priority grouping. Okay, so basically this is to set whether you are using group 5 or group 6 or group 7 based on that table, you know, the group table. So if you look at here, you look at inside, okay, this is actually the register we're modifying, the AIRCR. Okay, remember in the previous slides, I'm talking about AIRCR. Okay, why we want to modify this one is because your AIRCR bit 10 down to 8 is for your grouping. Any group number you want, you must write to this register bit 10 down to 8. Okay, so basically that's the task of this. You are modify bit 0 down to 8 to give the group value. Get it? And then lastly, you have, okay, so this one, this answers for the first two. And last one, you have another function, NVIC encode priority. So this is a code. Okay, so NVIC encoder priority. So here, okay, you need a priority group, you need a preamp priority, you have the sub priority. But inside this, if you look carefully, okay, you see it's doing something, okay, and then you know all this, but you see that we actually didn't modify any registers. We didn't modify any registers. So see there's a constant defined, okay, the group number, your input end with 07, okay, you are doing some calculation, okay, and you are defining other two local variables, okay, and then one of them is equal to this, okay, and one of them is equal to this. Basically you are selecting, if this one is true, you select this one, if this one is false, you select this one, okay, and this one as well. If this one is true, you select 0, if this one is false, you select this one. Is another value minus 7 plus this one. Remember what is this? For our particular case, what's the value of this? It's actually your tutorial question 2, okay? It's 5. Okay, so let me show you that. Remember this? We have this one, 5. Okay, it's a constant. It's told you that within your IPR, you can only modify 5 bits. Okay, the other 3 are hardware manufacturer reserved. Okay, so basically here, we didn't modify any registers. Right? What we return here, look at here. What we return here is basically a value. Okay, a value. So basically what we return is, if let's say you are calling this function. If you are calling this function, and you put value, let's say priority group 5, okay? And then preamp priority, let's say you put 2, okay? Sub priority, you put another number, let's say 1. What's happening is actually returning a organized 5 bits. Remember, in the IPR, okay, if this is IPR, it's totally 8-bit. And this 3 you cannot touch. And as a programmer, we need to write this 5 bits. Let's say for SysTick, we want 00000. That's it. Let's say our group is 5. Let's say we're using this one for preamp, using this one for sub. Okay, let's say for SysTick, this is the value we want. SysTick. And let's say for ENT3, you want it to be 01, and let's say 000. Okay, so the usage of this function is basically here, let's say I want to set my ENT3. I will put 5 here because I'm using group 5, right? 2 for preamp, 3 for sub. And the preamp priority level, I will put 01 because for ENT3, my value is 1. Okay, and for sub priority, I'll put 0. Then what this function does is it will output 01000 with correct format for me, and then I can later use it to put into my IPR. That's all. That's the function. Okay, so it's basically try to give the correct format. Okay, just like you send the document to the library and they will print out as the correct format for your thesis or report. You know, there's a rule for NUS, for example, your thesis, the font should be like 12, you know, the spacing should be how much. So there's some requirements. Similarly here, okay? So this function is just a library that helping people to get everything in the correct format. Okay, so the return, you can directly use the return to maybe let your IPR equal to that value. Okay, but it's not modifying any register. Okay, so basically that's the idea here is not directly write to any register, but encode the priority in the form required by the other function. Remember, a set priority is a function that you want to really set something, because inside this function you are changing the register values, right? You are changing the registers that in charge of the priority setting. So basically, this function, the return here is give you the correct format to put into this. Okay, that's the idea. Okay, so this end tutorial 5. Okay, so maybe I stop here. We have one more tutorial for UART, right? We'll finish it next week. It will be our last tutorial. And by the way, this Saturday I still have clinic, and I think I will discuss the past year paper questions. Since you haven't, okay, definitely you don't have time to do them first, right? So what I will do is I will we work together, okay? So I will mainly focus on the first part question, means all your assembly instructions. Okay, because those are a long time ago, right? You may forget about those. Okay, so let's review the part 1 first. Okay.
Morning.